Today we're going to be going in through lesson 6-9, which is all about writing polynomial functions. So we're going to take everything that we've kind of learned about polynomials and put it together. So before we get started on actually practicing writing polynomial functions, we're going to remember some things that we need to know in order to do this. So the first thing that we need to know is what the degree is. So remember, the degree identifies the number of zeros of a polynomial. So for example, if I have a function that looks like 3x to the third plus 4x squared plus x minus 3, the degree is that highest exponent or largest exponent. So in this case, the degree would be 3. And that will tell me how many total zeros the polynomial has. So they can be real or complex, imaginary, but there's 3 total zeros in that one. Second thing we need to know and remember is that the zeros are, and how to find the zeros and roots. So remember, in order to write a polynomial in factored form, we need to know where those zeros or roots might be. So for example, if I know that I am given the zeros are at 2 and -3, then I can write the factored form of the function as x minus 2 and x plus 3. So if we know the zeros and roots, we can write the factored form out. All right, the third thing we need to know is the multiplicity. So multiplicity is the number of times a specific factor occurs in a polynomial. So if we're writing in factored form, then we may have one factor that occurs more than once or only once, and that tells us some key things about the zeros. So if it has even multiplicity, the factor occurs an even number of times. So that would be like if the factor x minus 2 appeared twice or 4 times, right? So we would write it as an exponent, and so that even number, so again, this is even multiplicity. If it's an even number of times, then I know that the graph just touches the x-axis at that number. So touches, it means that it comes and bounces off that spot. So this one would be a +2, and it means that my polynomial graph touches it, and I always kind of say it bounces off of that spot. If the multiplicity is odd, so that factor occurs an odd number of times, so maybe like x plus 3 to the third, that odd degree there of that factor tells me that it has odd multiplicity. And when it's odd multiplicity, that means that it crosses the x-axis at that value. So if it's at x plus 3, that means it crosses at x minus 3. And that means that my function is going to come through that spot, cross the x-axis there, and then finish the rest of it somewhere else. But it's going to cross through it rather than just touch and bounce. So knowing the multiplicity of the factors helps me know how or to what degree each zero is raised. All right, 2 more things we need to remember and know. The first one is the complex conjugate theorem. So the complex conjugate theorem says that if a plus bi is a root of the polynomial, then a minus bi is also a root, and it works both ways. So if you find a solution of a plus bi, then you know that a minus bi must also be a root. And then finally, we have a point. Any point on the graph can help us. So keep in mind that a polynomial can be vertically stretched by any non-zero constant and retain the same zeros. So even though we know the zeros where it crosses and touches the x-axis, we need to know another point so that we can find the value of a to represent that stretch. That's going to tell us in the equation what the stretch is, and the point is going to help us figure out what that a value is. So, for example, if I have a function, our factored form may have an a out in front. So whatever our polynomial might be after that, if that a is out in front, it's a constant, and we would use the point to plug in and find the a value. So we would figure out how much it is. So we'll go through some examples next to get a feel for what that might look like. To start with here, we're going to look at a polynomial and kind of go through what the factors, the multiplicity, the behavior at x might be, and then the zero. So we're going to start by separating out the factors. So remember, the factors are each part. So my first factor is x. My second factor is the x minus 3. And my third factor is the x plus 2. So we're going to look at each factor individually and kind of name some things on it. So for the term x, the multiplicity of that, even though there's no exponent, we know that it's 1. So that makes it odd multiplicity. So remember, that means that it crosses the x-axis at that value. And the 0 that goes with it, what would make that factor 0, would be x equals 0. For our next factor, x minus 3, that is being raised to the third power. So that means that it is also odd multiplicity, which means it crosses at that value on the graph. And the solution for x that would make that factor equal 0 would be positive 3, because 3 minus 3 is 0. And then our final factor, x plus 2, has a multiplicity of 2, which is even. So that means that at the 0, it is going to just touch and bounce off that point. And the solution for x would make that a 0 would be negative 2, because negative 2 plus 2 makes 0. So just getting some practice of kind of what the polynomial looks like and then how those things might help me to eventually write the function. Okay, for our next example, we're going to start to write some polynomial functions. So we're going to use all of the given information to help us write these polynomials. So we're going to go through a couple, and then after we do one or two, I'll encourage you to pause the video and try some on your own, and then come back and check. So for this first one, they're telling us that it is degree 2. So I know that I am going to have a degree of 2. I have zeros at negative 5 and 3, and it tells me that there's no multiplicity on any of them. So that means each of them just occur once. We need to check to see if any of those need complex conjugates. So looking at negative 5 and 3, neither one of them is complex. So there would be no conjugates to go with that. And we're given a point 0, negative 30. So if it helps to write it as an ordered pair, that's the information we're okay. So we know that we are going to write a function of y equals, remember, there may be an a value that we need to find, so we always put that a out in front. And then I'm going to use these zeros that I was given to write some factors. So I know that if the solution is negative 5, that comes from the factor x. The solution of 3 comes from the factor x minus 3. So now what we're going to do is we are going to take that point we were given and we are going to plug it in for x and y and use that to see if there's an a value we need to know about. So let's look here. We're going to simplify a little bit. So when we simplify, we get negative 30 equals a times 5 and times negative 3. So that means we have negative 30 equals negative 15 when I multiply those two together times a. So I can see here now that I need to divide by negative 15 on both sides. And I find that a equals 2. So if a equals 2, that means that my final polynomial that I'm going to write out is 2 times x plus 5 and x minus 3. So that's it in factored form. If we need to, we can multiply that together to get it into standard form. So that would give me x squared. When I multiply the outsides and insides, that would make 2x. And then the last would be negative 15. And then I would distribute that 2, and I would get my final polynomial of 2x squared plus 4x minus 30. So that is our polynomial in standard form from the given information above. Okay, let's look at another one here. So in this polynomial, we are given a degree 3. We have zeros at 1/3, -5, -1/5. Again, no multiplicity, so remember that means that each one is just degree 1. All of my factors are going to be degree 1. And none of those are imaginary, so I have no conjugates that I need to include. And we are given the point 0, 5. So we're going to start with that y equals a again. My 0 of 1/3, I know that that comes from the factor 3x minus 1, because when I add the 1 and divide by 3, that's where the 1/3 comes from. I know that minus 5 comes from x plus 5. -1 comes from x plus 1. So again, I'm going to plug in the 0 and the 5 for my x and my y, and then fill in the rest of the equation that I already knew. Plus 5 and plus 1. So when I simplify there, we get a times -1 times 5 times 1, and that gives me -5a. So -1 is my a value. So when I write it out, I have a -1, 3x minus 1, x plus 5, and x plus 1. And then again, we can multiply that all together. When I multiply all 3 polynomials together, I get 3x cubed plus 17x squared plus 9x minus 5. So I multiplied these two together, and then I took that polynomial and multiplied it by this third one. And got 3x cubed plus 17x squared plus 9x minus 5. So my last step would be to distribute that -1 to everything. So I would get a final polynomial of -3x cubed minus 17x squared minus 9x plus 5. That would be my polynomial in standard form with that given information. All right, for part D here, we are given degree 3. And on this one, we can see that we have -1 and 2 with a multiplicity of 2. So that means that the factor that gives us a 0 of 2 is occurring twice. So we'll keep that in mind. None of those are imaginary, so we don't need any conjugates. And we are given the point 0, 12 to plug in to see if there's an a value. So let's write it out here. We're going to find an a value potentially. The 0 of -1 comes from x plus 1. And then again, this factor that would give us a 0 of 2 is x minus 2, and that has a multiplicity of 2, so we'd put that squared there. So I'm going to take my 0 and plug it in for the x's, my 12 for the y, and then let's fill in around it. So that would look like that. We would have a times 1 and a times -2 squared. So -2 times -2 is positive 4. So when I simplify that, I get 4a, which means 3 is my a value. So when I write it out, I get 3 times x plus 1 and x minus 2 squared. So if I want to multiply those together, this one, the first thing I would do is I would square that x minus 2 factor, and we want to remember that that means that you're multiplying x minus 2 times x minus 2 all the way out. That would give me x squared minus 4x plus 4. So remember, we don't just square each term, we got to FOIL the whole thing out. Then I would multiply the x plus 1 into that factor. I would get x cubed minus 3x squared. I would get, then I would just have a 4. So once I distribute the 3 into that, we would have 3x cubed minus 9x squared and plus 12 as my final polynomial. So you start to kind of see the pattern of what's going on here. We take the given information, make the factors, solve for a using the point, and then we write it in factored form, multiply together, and get the standard form. Okay, let's look at another one here. So this one is degree 3 again. I have the zeros of 5 and negative 2i. So I noticed that negative 2i there. That tells me that I also am going to have a 0 at positive 2i as the conjugate. Any imaginary complex number we need to have the conjugate with. And then for this one, we are given the point 0, 160. So let's go through and write this one out. So I have y equals a, x, and then it's going to be a minus 5 to give me a 0 of 5. I've got x plus 2i and x minus 2i. So that's where that complex conjugate is. Now I can see how I have 3 factors that give me the degree 3. Okay, let's plug in our point here. So we have 160, and then I'm going to plug in zeros for the x's. All right, let's start simplifying here. So we have a negative 5, we have a 2i, and we have a negative 2i. So when I multiply all that together, well, let's just start actually with the imaginaries. When I multiply those imaginaries together, I get negative 4i squared, and we should remember that that is the same as positive 4. So I squared is negative 1. When I multiply that by the negative 4, I get a positive 4. Just a little bit more room here. So we can multiply those together and get negative 20 times a. Divide both sides by that negative 20, and we would get that a is negative 8. So my factored form polynomial here is going to be negative 8 times x minus 5, x plus 2i, and x minus 2i. And since this one has the imaginary roots, you can just leave it in factored form. We do not need to multiply that one all the way out. I would again encourage you to maybe pause the video, try a couple of these last two on your own, and then see if you can come back and check your work. Okay, so for this one, we have 4th degree polynomial. So we're going to have 4 factors that we need to write out. This one says that 4 has a multiplicity of 2, and we have a complex of negative 3 plus I. So what I know is that if I have a negative 3 plus I, then I must also have a negative 3 minus I because of that complex conjugate theorem. And then they are giving me the point 0, 160 to use. Let's plug everything in. We have y equals a. We have a 0 of 4, which means it comes from x minus 4. That has a multiplicity of 2. And then I also have x minus negative 3 plus I, and x minus negative 3 minus Okay, so that's how I would write my complex zeros into my factors. Okay, so we're going to plug in our key points here. So we're going to plug in 0 for all the x's, and we're going to plug in 160 for y. Then I am going to fill in around that the other information I already had. So just copying this down. All right, so this one's going to be a little trickier to simplify, but I think we can do it together. So we're going to have an a value, 0 minus 4, that would be negative 4, squared would be 16. So 16 there. And then I have, if I distribute this negative in here, I would have 3 minus I. And for the second one, same thing. If I distribute that, I would have 3 plus I. Multiplying those together, those two complex terms together, or factors together, would leave me with 9 minus I squared. So we get a difference of squares there that multiplies back together. And then we remember that I squared is negative 1. So this is really 9 minus negative 1, which is 10. And now we're down to some real numbers that we can find an a value for. So 16 times 10, that's 160. If I divide both sides by 160, I get 1 for a. So this one has an a value of 1, which means it's normal. We don't need to write anything special. So my factored form, again, this one has complex, so we're just going to write it in factored form and be done. So this one, we don't need to write the a value of 1 because 1 times anything is still itself, so it doesn't change the values. We have x minus 4 squared. We have x minus negative 3 plus I. And we have x minus negative 3 minus I. So you will notice that it is the same thing we started with, but we had to double check to see if that a value was going to change or not. Okay, for our final problem here, we're going to write a polynomial from this graph. So this time I'm given some different key points. So on this one, I am given my intercepts or my zeros from the graph. So I need to identify where all those are, and then I can write out my factored form. So I'm just going to annotate them over here. So this is at negative 5, this is at negative 2, we have one at 0, we have one at 3, and we have one at 6. So I'm going to start with the one at 0, only because it's just x, and we usually just put that out in front. You could put it in the middle, it wouldn't be a big deal. But I like to get that one on there first, and then I just work from left to right or right to left. So we can do x plus 5 for this negative 5, 0, x plus 2 for this guy. We already have the 0, x minus 3 for the positive 3, and x minus 6 for that one. And that would be our factored form from the polynomial. And we're going to pick a point, one of those x-intercepts that I just found. So I'm going to pick 3, 0. You could pick the other ones if you wanted. And I'm just going to plug them in to make sure that I am getting out what I think I should, to see if there's an a value or not. So plug in 3 for all of these x's. And what I can see is that I have 3 times 8 times 5, and then I get times 0, and that's what I need to make sure happens, because anything times 0 is going to equal 0. So that tells me that we're good. We don't need an a value of any sort to make that happen. So that is how you write polynomials given different information. We'll see you next time.